Welcome to lesson 10.1. This lesson is going to start us on our quadratic equation and function chapter. All right, and this is going to piggyback off of what we learned in the last chapter. Okay, so today what we're going to talk about is we're actually going to talk about graphing quadratics when they are in the form of y equals a to the x squared plus c, where a and c are just different numbers. Okay, so let's talk about what exactly I mean by a quadratic equation or a quadratic function. Okay, so a quadratic function is a non-linear function that can be written in the standard form y equals ax squared plus bx plus c, where a does not equal 0. Okay, so a is anything but 0. Today what we're going to do is we're going to focus on when we do not have this bx term. So that's why it doesn't have the bx in here. Okay, so every quadratic function has the same shape. It's called a parabola. A parabola looks like a U. Okay, so we're going to talk about how to do that today. But first, I want to talk to you about what what it looks like. So we have the parent quadratic function, which is y equals x squared. That means that we simply have this great U shape, as you can see, and it goes through its 0.00, okay? And that 0.00 is called the vertex, okay? It is the lowest or highest point in a parabola, okay? So in this case, it is the lowest point in the parabola, okay? We also have something called an axis of symmetry, okay? An axis of symmetry. An axis of symmetry it acts as sort of like a mirror, okay? So in this case, it is going straight down the y-axis. This does not always happen. Sometimes it's, over here on 3 or over here on -5, okay? But this axis of symmetry tells us that whatever is happening on, let's say, the left side of our quadratic function, it's going to look exactly the same on the right side of the quadratic function, okay? So our parent quadratic function, as I said earlier, is y equals x squared. So every graph that we are going to graph today, or we're going to look at today, is going to look something like this. It might be skinnier, it might be fatter, okay? It might be up like this, it might be upside down, okay? So we're going to look at how those different graphs look, okay? So our first example is if we are given this function y equals 3x squared and I want to graph this function. Just like we did with our linear function, so remember when we went back and we were graphing lines, we started with just making a table, okay? That's the same thing we're going to do here. So I'm going to pick various points for x and I'm going to just plug it in and to get my y terms. So my x terms, these are always safe bets to go for, are going to be -2, -1, 0, 1, and 2. If I were to plug in -2 to x squared, we would have 3 times -2 squared, okay? -2 times -2 would be 4, and 3 times 4 is 12, okay? That's how I get the 12. So on and so forth. 3 times -1 squared. Well, -1 squared is 1, so 3 times 1 is 3. 0. 0 squared is just 0. 0 times 3 is 0. Okay. 1 squared is 1 times 3 gets you 3. 2 squared is 4. 4 times 3 is 12. Now, before I look at anything further, I want you to really notice, okay, that we have an area right here where all of a sudden it's repeating itself, okay? So we've got a 12, a 3, a 0, a 3, a 12, okay? That's what's going to get you that U shape. All right, from here, we're just going to plot the points from the table. Okay, so we are going to be looking at the red parabola here. Okay, that's my function. So I graphed -2, 12. I graphed -1, 3. I graphed 0, 0. I graphed 1, 3. And I graphed 2, 12. And I just simply draw my U through my points, and there's my function. Now they're showing the picture with the parent function on here. So this blue line is our parent function. It's y equals x squared. Okay, so if you notice this one, it's a little bit skinnier, okay, than the parent function, and it is still facing upward where my vertex is my lowest point. Okay. All right, so let's look at another example. All right, so in this example, it says graph y equals -1/4 x squared, and then compare it to the graph of y equals x squared. So remember, this is our parent function. So we're just going to see how it compares to this blue line, or parabola. Okay, so same sort of process as before. I am just going to make a table. All right, so I'm going to slide this over here. Okay. So the first thing I'm going to do is I'm going to pick some points. In this case, I picked -4, -2, 0, 2, and 4. You can still pick just -2, 1, 0, 1, 2 if you want. It's totally up to you. Okay. And I'm just going to plug in this information. So -4 squared is 16. 16 times -1/4 is -4. So on and so forth. Okay, got my points here. Next thing is just to plot my points. Again, my red function is what I am looking at. So I have point -4, 4. I have -2, -1. I have 0, 0. I have 2, -1. And I have 4, -4. Okay? Immediately you should notice something that's very different than our original parent function. Okay? It's upside down. So our blue function is still our parent function. Our red function, our new function, is going upside down. Okay? It's also really big. It's like really wide. Okay? So when they ask you to compare the graph with the graph of y equals x squared, what they're looking for is exactly what I just explained. Okay? It is wider than the parent function, and it is upside down where my vertex is my highest point of my parabola. Okay. Now, looking at this function, the y equals -1/4 x squared, versus the other function I graphed, the y equals 3x squared, which goes upward, I can make a generalization, and that's this down here. This is very important right here. So it says, examples 1 and 2, which I just showed you, suggest the following general result. The parabola opens up when the coefficient, so the number in front of x squared, is positive, and opens down, so like this, when the coefficient, or the number in front of x squared, is negative. This is very, very important to remember. Write it down. Memorize it. Be friends with it. Put it in your long-term memory bank. Okay? So, so that's basically how you graph these functions. It's very simple. Okay? I'm going to show you 2 more examples just to show you a couple other changes that can happen when we have a parabola, okay? Because if you remember, we were talking about functions that were y equals ax squared plus c, and so far we don't have our plus anything here. So the next 2 examples are going to show that for you. All right, so I have y equals x squared plus 5, and I'm going to again compare it to my parent function, y equals x squared. Okay, The same thing as before, I am going to make a table of values. So I'm going to pick random numbers. I'm going to pick -2, -1, 0, 1, and 2. And I'm going to plug them in for this information. So -2 squared is 4. 4 plus 5 is 9. -1 squared is 1. 1 plus 5 is 6. 0. 0 squared plus 5. 0 squared is just 0 plus 5 is 5. 1. 1 squared plus 5 is again 6. If you're noticing a pattern, take a guess. 2 is 9. All right, so from here I'm just going to plot my points on my graph and I am going to compare it to my parent function. Okay, so that is my parent function, again, is this blue line. The biggest difference to my red line, once I graphed all those points, is that it is 1, 2, 3, 4, 5 spaces or points above my parent function. Okay, so it's pretty much the same shape. It's just higher up. It's had a vertical translation. Okay, 5 units up. So you would graph it, and then you would say compared to the graph, it is still a positive graph because again, x squared is positive, but it has a vertical translation or it's moving up 5 units. Okay. All right, let's look at another example. I have y equals 1/2 x squared minus 4. Okay, so immediately when I'm looking at this graph, at this equation, function, 1/2 is positive, so I can safely assume that my parabola should probably be upward, like this, a normal U, not an upside down one. And I'm dealing with this -4. So in the past, in the other example, it was +5 and it moved up 5. So take a guess. It's -4. What do you think is going to happen? Well, let's see what and find out. Same process before. I'm going to make a table. In this case, I'm picking -4, -2, 0, 2, and 4. I'm not going to bore you with how to plug it in. You know how to do this math. I've seen you do it many times before. Okay, get my point. So I've got -4, 4, -2, -2, 0, -4, 2, -2, and 4, 4. So I am going to go through, graph these, red curve. If you properly assumed that -4 means that it's going to go down 4 points, then you're correct. Okay, this C tells you whether or not it's moving up or down. If it's positive, you're moving up. If it's negative, you're moving down. Okay? All right, so if we were to compare this to my original parent function, the blue function here, I would just say that it is wider than my parent function and that it is 4 units down, or it has a vertical translation of -4. Okay? All right, so just to take all the material we have learned about in this video, I have this lovely, kind of confusing looking chart for you, okay? But this is basically sums up what we talked about today. So if I have an a or a number in front of x squared, and that number is bigger than 1, so it's 3, 4, 5, 20, okay? My parabola is going to get really, really skinny, okay? If my a is somewhere between 0 and 1, so it's something like 1/2, 3/4, 2/3, 3/5, 1/9, whatever. It's going to get really, really, really wide, really fat, okay? All right, exact same idea if a is less than -1, okay? So that same idea, if it's like -2, -4, okay? It's going to be really, really skinny, but in this case, it's going to be upside down because it's negative. Okay, same thing with if it is somewhere between -1 and 0. It's going to be really, really fat. So let's say this is -3/5. I know it's going to be bigger than my parent function, but it's also going to be negative. All right, and then that last thing we just did the two examples on, whenever we have a plus C or a plus number, +5, +2, +30, okay? If it's plus, if it's positive, we're moving up. If it's -25, you're going to go down 25. Okay? I don't think you'll ever have a situation where you're dealing with +25 or -25, but you get my picture. Okay? So this is a good thing to write down and to remember and to start to commit to memory, because these will help you determine whether or not your graphs are looking correct when you're making the tables. Okay? If you make a table and all of a sudden your graph should be positive, but it's turning out negative, you might want to go back and check your math. Okay? That's all I have for you. I know this was a lot of information. Okay, make sure you take a lot of notes. Otherwise, tomorrow, come in with any questions. Thanks.